Hello and welcome to this video about math mixed with computers. In this video we'll learn how to get a table containing all of the first n derivatives of the inverse tangent function. I've already made up similar videos on how to get tables of the first n derivatives of tangent and inverse cosine, so I'll go through all the code, but only concentrating on the code in this program that's different from these two functions. So we need to derive expressions for the inverse tangent function, so as to be able to create code so as to get all of the derivatives of the inverse tangent. We'll start off with this expression in which one variable is the inverse tangent of the other. So this is the derivative of inverse tangent in dash notation, and we'll write it out in indice notation so as to better find its derivative. We'll assign a variable u to be equal to this function. Then we'll calculate the derivative of u and express it in terms of u. And this is the second derivative of u. We'll assign w to be this arbitrary term, where x and u are raised to the power of these integers. And so this is the first derivative of w. It splits into two terms, so that in the program we'll have two terms splitting from any one term when we try to find the derivative of it. This is similar to the tangent and inverse cosine functions. We'll use this in the program to construct the next derivative from the previous derivative. So this is the data structure that we'll be using, an array of pointers that point to the start of each derivative expression in another array. And this is how we'll construct the next derivative from the previous one. We'll use the splitting equation that we found earlier to get the next derivative, and then we'll use these two functions to simplify it. The first one gathers like terms together, and the next one eliminates the zeros, and then we'll place this new derivative after the previous one in the table. This is the code used to construct the next derivative from the previous one. We'll get the start and end of the derivative we're working on, and make a loop to construct the derivative from it. We'll get the terms from the table array that's stored as 3 numbers for each entry. We'll then get the numbers for the constructed term in the array. This part is different to tan and inverse cosine. Then we'll place these numbers into the next derivative, but we've still got to do more work on it. We'll then store the new length of this newly constructed derivative. So this is the function that gathers like terms together, adding their coefficients. This function is identical in all of the programs used to find derivative tables. This is the function that eliminates zeros in the newly constructed expression. It does this by having one indexing integer lag another, so that zero terms are written over and thus erased. This function copies the newly created derivative into the derivatives table. This function creates an entire table using the 4 previous functions. It is mostly the same for all of the derivative finding programs. Its initial input contains different variables, but the data is the same. This function tests the table using numerical differentiation. One derivative is tested against the next derivative. We're using different formulas circled in red. We're using a good range of input data as well. That should give data that's good for testing using numerical analysis. So we're calculating the values of the derivatives here, and we're performing numerical differentiation here. And if the difference between these two derivatives isn't close enough to 0, then we'll return an error message here with values of variables so as to debug the code. And in this function we'll make the table and test every derivative in it. And here we'll print out all the values of all of the numbers in the table array. And in this function we'll print out the table as algebra. It's nearly the same as the inverse cosine printing function, only we're writing inverse tangent at the beginning. And this is where we'll print it out using the rules of algebra. We'll use this code circled in red to put a new line in the expression if it gets too long. And this is the table written out as algebra. It has the same sort of behavior as for the other tables, not growing too long too quickly and having large constants. Please look at my previous video called the nth derivative of tangent and of inverse cosine. to get a deeper understanding of how a lot of these functions work. So I hope that you have found this video to be helpful and interesting. Please click like and subscribe if you did. Please leave some helpful thoughts in the comments. It's common to make a lot of errors in these math videos, since they can creep in through the most vigorous error-checking processes. So if you did find one, please leave its exact location and description in the comments, rather than click dislike. It's not nice to do this on anyone's math video, because they try reasonably hard to error-proof it. Feel free to share this video, and thanks a lot for watching.